My dear students, welcome back. My name is Dr. Rakesh Mang. I am Assistant Professor Physics, ABSIT Ghaziabad. In Unit 4, that is wave optics, again we are going to discuss another important topic from diffraction, that is double slit diffraction. So before we start discussing about the double slit diffractions, let us draw the diagram so that you will understand what is double slit diffraction. This is also another concept of Fraunhofer diffraction where source and screen are at infinite distance. Let us draw the diagram first. Because it is a Fraunhofer diffraction, so we have again two lenses. In these two lenses, because source is at finite distance, but we are putting the lenses हम इसलिए लगा रहे हैं ताकि आपको ये लगे कि जो बीम है it is coming from infinite distance. Here you have a screen. This is your screen. This is your source. The light beam is incident like this. Incident on the screen at a point P. Let us draw the diffracted version of it. So, if your double slit is here, then the diffracted version or the bent version will incident at this place, which is nothing but P dash. So this is X, Y your screen. Then let us draw a normal. Like this, and all the points. So slit S1, slit S2. This is your E plus D. I will explain what is E plus D. Let us give the names A, B, M, C, this is your D. This angle is theta, this angle is also theta. So this is double slit diffraction. Let us now know about what is happening in the double slit. Double slit में क्या हो रहा है उसको हम डिस्कस करते हैं. Let a plane wave front be incident normally on two slits AB and CD of equal width E and separated by an opaque distance D. So what we have these are two slits. This is one slit, this is another slit, and this is your opaque space. Slit S1, slit S2, this is your opaque space. ओपाक स्पेस का मतलब है जिसके थ्रू से लाइट पेनिट्रेट करके दूसरी तरफ नहीं जा पाए, उसको हम ओपाक स्पेस कहते हैं. सो द डिफ्रैक्टेड लाइट is focused on the screen XY. The diffraction pattern on the screen consists of equally bright and dark fringes due to interference of light from both slits. The observations are: first, all points in slits S1 and S2 will send secondary waves. Second is all secondary waves moving along the incident wave will be focused at P and the diffracted waves will be focused at P dash. And the third point is the amplitude at P dash is the resultant from two slits, each of amplitude R is equal to A sin अल्फा बाय अल्फा. हमने पहले भी सिंगल स्लिट में डबल स्लिट की जो कंडीशंस है ये हम डिस्कस कर चुके हैं. दिस इज कॉल्ड इंटेंसिटी पैटर्न. सो लेट अस derive out the conditions. S1M is the perpendicular on S2M. S2M के ऊपर S1M perpendicular ड्रॉ किया गया है. So the path difference S2M is equal to E plus D sin theta. This is your equation number 1, where E plus D is called the double slit. This is your path difference. You can derive out the phase difference also, क्योंकि आपको पता है phase difference is 2 pi by lambda into path difference. तो इसकी वैल्यू हो जाएगा phase difference is equal to 2 pi by lambda into E plus D sin theta. इक्वेशन 2. इसको हम एक दूसरा टर्म यूज करेंगे 2 बीटा, where बीटा is equal to pi by lambda E plus D sin theta. Next, we'll resolve out the resultant by using vector additions. तो आर की रिजल्टेंट आर डैश होगा, तो आर डैश की वैल्यू हम कैसे डिटरमाइन कर सकते हैं? आर डैश स्क्वायर which is equal to resultant amplitude at P dash, which is equal to two RR cos 2 beta, which is equal R square plus R square is equal to 2RR cos 2 beta, which is equal to 2R square 1 plus cos 2 beta, which is equal to 2R square 2 cos square 2 beta by 2, which is equal to 4R square cos square beta. Equation 3. So we got the resultant R dash square is equal to 4R square cos square beta. Can also be written as R dash square is equal to 4 A square sin square alpha by alpha square cos square beta, where we have used R is equal to A sin alpha by alpha. Let us now come to the intensity part. As the intensity is perpendicular to the square of the amplitude, so intensity at P dash will be I is equal to 4A square sin square alpha by alpha square cos square beta, where alpha is equal to pi E by lambda sin theta, beta is equal to pi by lambda E plus D sin theta. So So these are the conditions. So let us come to the observations. What are the observations? Because this is your final intensity for double slit. Intensity. In the observations, the intensity resultant intensity at any point is the contribution of two factors. First, the factor a square sine square alpha by alpha square, which is nothing but intensity of individual slit. जो सेकेंड पॉइंट है the factor cos square beta represents the interference pattern due to the waves from two parallel slits. Let us come to the maxima and minima. The diffraction pattern is square sine square alpha by alpha square gives the central maximum in the directions theta is equal to 0 and followed by minima and secondary maxima of decreasing intensity. So minima is given by E sin theta is equal to plus minus m lambda or sin theta is equal to m lambda by E, where m is equal to 1 2 3. The secondary maxima is obtained in the directions given by alpha is equal to plus minus 3 pi by 2 plus minus 5 pi by 2 plus minus 7 pi by 2 and so on. तो सेकेंडरी मैक्सिमा की ये पोजीशंस है, मिनिमा की कंडीशंस ये है। अब अदर टर्म कॉस स्क्वायर बीटा के बारे में डिस्कस करेंगे। द इंटरफियरेंस टर्म, आपको पता है डबल स्लिट डिफ्रैक्शंस में इंटरफेरेंस और डिफ्रैक्शंस दोनों फिनोमेना हम ऑब्जर्व कर रहे हैं। कॉस स्क्वायर बीटा इज शोइंग इंटरफियरेंस और पहला टर्म ए स्क्वायर साइन स्क्वायर अल्फा बाय अल्फा स्क्वायर गिव्स द डिफ्रैक्शन। The interference cos square beta gives the maxima direction cos square beta is equal to 1 और बीटा इक्वल टू प्लस माइनस n पाई और n lambda where n is equal to 0, 1, 2, 3 and so on. In the direction theta is equal to 0, the central maxima due to interference and diffraction coincide. तो थीटा जब जीरो होता है तब इंटरफेरेंस और डिफ्रैक्शन एक जगह पे बनता है, इसकी वजह से वहाँ डार्क नज़र आता है क्योंकि मिनिमा मैक्सिमा को ओवरकम कर लेता है। सो दी मिनिमा ड्यू टू द इंटरफेरेंस टर्म इज cos square beta is equal to 0 और beta is equal to plus minus 2n plus 1 pi by 2 और e plus d sin theta is equal to plus minus 2n plus 1 lambda by 2. Let us have, so the intensity distribution curve due to the diffraction term and interference term and the combined effect is as follows. हम डायग्रामेटिकली इस चीज को भी डिनोट करेंगे। तो दिस इज द कंडीशन, द सेंट्रल कंडीशंस विल occur here how will all the figure will generate? ये 0 पॉइंट है सभी में. This is your individual slit diffraction pattern. This is your interference pattern. You will see the intensity is uniform in interference pattern. Give the names 0, pi, 2 pi, minus pi, minus 2 pi. Here it is 0, pi, 2 pi, 3 pi, pi, 2 pi, 3 pi, and the resultant is like this. Where the individual diffractions pattern will enter into it. So this is your diffraction pattern, interference pattern, combined effect. So this completes your calculations related to double slit diffractions. So in the next class we will know about what is missing order spectra.